mess. So this European Commission, International Electrotechnical Commission, they came up with a standard. It's the IEC 6113 something something. Maybe it's in the text, I don't know. But this international, this committee came up with a standard and said, okay, we're going to establish 4 different programming languages that all PLCs should be able to support. And that's what happened. Siemens had it. Allen Bradley, the newer stuff, has it. The legacy stuff does not support that. But finally, we have a standard out there that all languages can support. That way, when Christopher goes and looks at an Allen Bradley program, he sees, let's see, he sees function block. Then he can go to Siemens, the Siemens program. Okay, yep, I understand what that's doing. Let's see.
I have a question about the continuous task.
Continuous that?
Yeah. In your PowerPoint, you said that it has the lowest priority. Is that to be interpreted as under the continuous task, those are the most, with being the most priority, are we saying it's the most basic of tasks in the facility being done? And because they're the most basic, they're not given high emphasis?
Right, that's right. Because if you think of an event type task, it's like a fall condition or some kind of emergency condition. So yeah, it's like high priority. Yeah.
Did you say that organization was the International
Electrotechnical Commission.
IEC?
Yeah. If you can look up IEC 6113 B or C, I can't remember what it is. But that's where we go. What are tags used for? What are tags used for?
Name and description. Or just say, this is doing this.
Addresses.
Yeah, addresses. So they basically become our addresses. And the good thing about it, we can put a good descriptive name on those tags and say pump, well pump, or whatever.
Hopefully not in Romulan.
Sump pump, fill pump, discharge pump. Yeah, and that name becomes the address. Let's see. Compare the accessibility. What's the difference between program scope and controller scope tags? What's the main points to that? Program scope and controller scope tags.
The program scope tag has data that can be accessed only by routines within a specific program or local data. I think, because I'm just doing this from memory.
Yes, good, local, yes. That's the key word, local, it's local data, yeah.
And controller scope would be global data.
Yes, good. And I know right now this stuff doesn't mean anything to you right now, but it will. It'll all come clear. Let's see. 13, name the tag type used for each of the following. Create an alternate name for a tag. Alias, yeah. That's a given. Alias. Or AKA, right, also known as, yeah. So you create a tag, and then you create another tag that references that tag, but the tag you created becomes a different name. But it's all just a mirror image of that other tag with just a different name. So it's like AKA, also known as, it's an alias. Share information over a network. Yes, reduce platoon. Does anybody know what that is?
Produce sends data and consume receives data.
Yeah, that's right. That's right. So if we have, let's say we have, we'll just keep it simple, 2 PLCs on a network. We have a PLC in this room, then we have a PLC that's in a panel against the wall over there. And they're connected by an Ethernet cable. They're on a network, we set up produced and consumed tags to send and receive data. So if we're gonna send some data over to that PLC, this PLC would have a produced tag in it called my tag. The consumed, or the other PLC that's receiving it, will have a consumed tag called my tag. Has to have the same tag name. That way you can pass bits back and forth. Does that make sense? Maybe some kind of interlock.
Is it produced and consumed have to have the same name?
Yeah. Maybe you want to set up an interlock, say, we're running a small assembly line, and on this assembly line, maybe we have some torque machines or something, some kind of a torque gun that can get out in the way of these parts running down the assembly line, right? We don't want that torque machine out here while parts are running down the assembly line. It's gonna tear it out of the dang ceiling, right? So the PLC in this torque machine sends a produced tag over to the assembly line PLC and says, hey, I'm out in the way, do not move anything. Stop what you're doing, right? I don't want you moving parts, because if you do, you're gonna tear me out of the ceiling. You get it? All you're doing is sending a bit. And here's the power behind it. You're not having to hardwire things, right? Otherwise, you'd have to hardwire an output from this PLC into an input to this other PLC. Make sense?
I have
Some kind of a tooling proc switch or something.
a question, Mr. Hand. With this produced tag and the consumed tag, is it always a 1-to-1 ratio within the two locations? Or do the number of tags being produced and consumed vary?
Yeah, you can set up whatever you want, pretty much. Yeah.
So if you're sending 20, you're receiving 20, but you're not, there's no spares in case you have an issue with the information being sent. There's no backup.
Right.
Okay.
So we used to have to set, and a lot of you guys that are in industry see this too, using a lot of hardwired stuff. Like you might have a proc switch that tells the assembly line that some kind of tooling is out in the way. Well, that proc switch is wired back to the PLC in the machine that's out of the way, and in that machine, an output from it is wired into an input to the main PLC. That's the way it used to be done. It was a hardwired connection from one PLC output to the input of another PLC as an input. That's just the way it was. We used to have it's an interlock is what it is, used for interlocks. Right. Prevent something from happening, some kind of safety thing. Let's see. Share information, store various types of data. What kind of tag is that?
Base.
The type, tag type that you would use to store various types of data.
Base.
Base tag? Yeah. Yeah. So, and you're gonna be hearing a lot about data types in here. We'll get into that in a little bit. What's the difference between a produced tag and a consumed tag? Okay, you know what that is. 16, state the data type used for each of the following: a 32-bit memory storage. Real. Dent, yeah. So double integer or real, right? A double integer is, how many bits are in an integer? 16, yeah, so a double integer would be 32. And the real data type, it's just like the F8 file in the SLIC 500 MicroLogix. I think we might have talked about that, just a little piece of it. It's that F8, the floating point,
Yeah,
where the decimal can move.
the thing you said we'll never use.
Yes, right. That's right. But it's the real data type in the logics. And it's also in Siemens too. That's the good thing about it. This will get us, go ahead into Siemens production too. On, off, toggle switch. A bull, yeah, which is also binary, right? Same data types are in the micrologic. What's some of the data types in the micrologics? The B3, that's the binary, right?
T4,
Integer.
C5, N7,
Yeah, editor, yeah,
F8.
yeah. That's the data type. 16-bit memory storage.